So we're going to use the angle sum formulas. So last section, we developed the angle difference formulas, which build the angle sum formulas, which build the sum to product formulas and that angle wave formula and the product to sum. And so we're going to develop a couple more, and we're going to start with, let's see, how about the sine of alpha plus beta, which is equal to the sine of alpha times the cosine of beta plus, sine always has the right sign, cosine alpha sine beta. And what we're going to do here is we're going to say, well, let's let alpha equal beta. If that's the case, then alpha plus beta is really alpha plus alpha, which is 2 alpha. And if I apply that here, then I get on the left side, the sine of 2 alpha is equal to, alpha is beta, so we're just going to replace the betas with alphas. So that's going to give me the sine of alpha cosine, of alpha, so we just have alphas now, plus cosine of alpha sine of alpha. And it doesn't matter whether I multiply sine cosine or cosine sine if the angles are the same, so these two are the same thing, so that means I get twice the sine of alpha cosine of alpha. So now I have a new formula, and this is called the double angle formula for the sine. And so we're going to do the same thing for the cosine. So this is a very, 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 very important one. And I'll make a list in next class about what the most important ones in my opinion are, and the others we just look up when we need them. So stuff that should be committed to memory and stuff you can just look up someday. All right, so cosine, what's that one look like? So cosine of alpha plus beta is equal to the cosine of alpha cosine of beta. But the cosine doesn't get the signs right. If there's a positive here, there's a negative there. Now we switch to sine alpha sine beta. And then same thing, we're going to apply this logic up here. We're just going to let alpha and beta be equal. So these are all alphas. So over on this side, we're going to get the cosine of alpha plus alpha, which is 2 alpha, equals cosine alpha minus sine alpha sine alpha. And on this side, we should notice that, well, cosine times cosine is cosine squared if the angles are the same. So that's cosine squared of alpha minus sine squared of alpha. And my hope is you're looking at that and saying, wait, that reminds me of another identity. All right, so double angle formulas. This is the cosine double angle formula. But wait, there's more. All right, so again, important. Double angle, sine of a doubled angle is twice the sine of the single angle cosine of the single angle, right? You can also reverse that and get a half angle formula, which we'll talk about very soon. But I'm curious about this sucker right here, because that looks really familiar. That reminds me of the Pythagorean identity. So this one right here is like Pythagorean. Right, remember the Pythagorean is not a difference of the squares, but a sum of the squares. Pythagorean says that if you take cosine squared of some angle plus the sine squared of that same angle, doesn't matter what the angle is, you always get 1. Turns out if you take the difference of the squares, you get, oops, I made a typo there, cosine of 2 alpha, double angle. We take the difference, we get the double angle. But these two are related. So I want to look at the relationship between these two, which gives us some other ways of viewing the cosine double angle. So I'm going to take my Pythagorean identity, cosine squared of alpha plus sine squared of alpha, equals 1. And we've used that in other ways, like we've written the cosine on the other side or the sine on the other side. So variations of this formula right here are that the cosine squared of alpha equals 1 minus the sine squared of alpha, or going the other way, we've used it this way too in the past, 1 minus the cosine squared of alpha. And so these two are going to allow me to look at the cosine double angle in a slightly different way. So now let's consider the cosine double angle. Cosine of 2 alpha equals cosine squared of alpha. And because we have a minus, the order matters. Cosine has to come first. So cosine double angle, cosine squared single angle, and then sine squared. Okay, so the first thing I'm going to do is I'm going to apply this up there. So this says that if you have a cosine squared, you can replace it with 1 minus the sine squared. So I can just replace this part right here with 1 minus sine squared. So 1 minus sine squared of alpha is this part, and I still have a minus sine squared chilling out there. So I have 2 minus sine squareds here. So 1 minus 2 sine squareds of alpha. And it turns out this is an important version of the cosine double angle. So I'm going to highlight that. This is very, 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 very important. Now, if I could do the same thing, I could take my original double angle formula up here and I could replace the sine squared with 1 minus cosine squared. And if I do that, then I get another variation on this. I'm going to write that in a slightly different color here. Let's go blue. And I'm going to skip the work and just get straight to the answer. It ends up being twice the cosine squared of alpha, then minus 1. And that's important too. Okay, so why are these other versions important besides the fact that they were just fun to do? Because they lead to what's called the half angle formulas. So I'm going to take these two next and I'm going to rewrite them. These make half angle formulas. Because if you double one direction, you have in the other direction. So what I'm going to do is just I'm going to do a little angle swapping here. I'm going to take that 2 alpha and call it theta. So that means theta, or alpha, excuse me, theta is 2 alpha. Alpha could be considered theta over 2. And so I'm just going to swap them out. I'm going to do it in this one right here. So I'm going to rewrite that. So instead of a 2 alpha, I'm going to call that a theta. So cosine of theta equals twice the cosine squared. Instead of alpha, I'm going to call it theta over 2. So now instead of my focus being on a double angle, I now have a focus on an angle and a half angle. Okay, so I'm just reversing the direction. And then I'm going to solve for this cosine of theta over 2. So if I do that, I would add 1 to the other side. So that's going to give me, let's do it in blue, cosine of theta plus 1 brings the 1 over. Then I divide that by 2. And then I take the square root. And so what's left on the other side is just the cosine of theta over 2 equals that. And technically, when we take the square root of the square, we get a plus or a minus. So this is the half angle formula for cosine. It turns out it's important also. Now, similarly, there's going to be a half angle formula for the sine. And that one's just going to look a little bit different. We're going to have to subtract a 1, divide by -2. And so I'm just going to write the result next to this. So versus the sine half angle, so theta over 2, that's also going to be plus or minus a big old square root here. And then I'm going to get, let's see, I'm going to have to subtract my 1, divide by -2. That's going to switch the signs to 1 minus cosine of theta over 2 inside the square root. Okay, so because these have the minus in a different direction, then the other versions have the minus in the different direction. So things that you ought to know, I'm just going to kind of star those that I'd like you to know off the top of your head. Last class, I had recommended you memorize the angle difference formulas. They're pretty powerful. Here we have the angle sum, which is powerful too because it led to the double angle. So the double angle for sine is pretty important. So angle difference from last class, that's pretty important to kind of know off the top of your head for sine and cosine. Double angle for sine is one that's worth knowing. For cosine, there's multiple double angle formulas. And in my head, I have this one in the top of my head. I also have, the Pythagorean theorem. We've been doing that since we started the course, pretty much day one. And if you know the Pythagorean identity, you can easily switch that first version, that was supposed to be a star, there we go, that first version of the cosine double angle to these two. Alternatively, if you know these two, then you can always solve for this alpha, which gives you the half angle. So I kind of have this one memorized because I've taught this class many times, but really I have these down in my head. And I often use these when I need a half angle because I just kind of reverse the direction of it. Should you memorize these two? You can look them up when you need them if you don't know how to use these to get there. So we've developed a lot of identities here. And it's always a good idea to have an identity cheat sheet. And there's a lot of them available on the internet. So this one right here is the one I was using earlier in videos. This one's from Clark University. Purple Maths, acute 1-2. It's got the basic ones we've been working on since the beginning. The Pythagorean, which its variations. The negative angle version, angle sum and difference. We did develop the tangent angle difference last class. Double angle, various versions. The cotangent's not that important. We can always look that one up. And then the half angles come from the double angle formulas there. And then there's a ton of other ones. Sum to product, product to sum, and I think they stop there. If we were to go over to Wikipedia, they're going to have 10 times as many. Look at that beautiful version of the unit circle, of those special angles there. Yeah, and then they have just a ton listed there. So you can kind of scroll through and look around. So Wikipedia is like, this page right here is pretty much our textbook without any examples. It's got every formula, not necessarily how to use them. Formulas I've probably never used, but maybe. Wow. All right. So let's apply some of these. Let's see, new page, new video. I'll be right back.